Hello everyone. Let us try to solve a simple problem on discrete convolution. Good evening everyone. Let us try to solve this simple problem. So if you go through the problem statement, we are given with a discrete sequence x of n and we are given with h of n. So what we know is h of n is nothing but the impulse sequence, right? And h of n is given as delta of n minus delta of n minus 3 plus delta of n minus 5. And we are asked to determine y of 5. So before going to the solution, if you observe the problem statement carefully, what we can understand is x of n is my input sequence, that's obvious, and h of n, the impulse response, is sum of or a combination of impulse sequences, right? H of n is impulse response, which in this case is a combination of impulse sequences, right? So now let us try to find the best possible way to simplify this problem. So how we can proceed is, we are given with x of n and we are given with h of n, and what we need to find is y of 5. So basically, first let us try to find the output response y of n. So for any given system, that may be continuous system or a discrete system, the output response is always the convolution of input and impulse. So as we are dealing with discrete sequences, so obviously my output response y of n is the convolution of input sequence with impulse response, which we usually denote as this equation, right? Y of n is equals to x of n convolution h of n. This is the symbol for convolution, right? So now in this case, if you observe, things are very clear. We know x of n and we know h of n also. So now what we need to do, so immediately what we can do is, wherever you find, or instead of h of n, you just replace the given impulse response, right? So before that, if you recall the properties of impulse response, we have two great properties, out of which the first one states that the convolution of any input sequence with impulse sequence gives you the input sequence only. So mathematically, x of n convolution delta of n is x of n itself. Also, the time shifting property, what it states is x of n convolution delta of n minus m is nothing but x of n minus m. So by using these two properties, we can simplify the problem very easily. So now, as I said earlier, what we need to do in this equation, wherever you find h of n, or instead of h of n, initially let us try to replace the given impulse response. So now if you observe, my y of n is nothing but x of n convolution, my h of n is delta of n minus delta of n minus 3 plus delta of n minus 5, right? So now if you observe, what we can do, you try to expand this, right? So how can we expand that? Y of n is equals to, you apply or you convolute the given input with each of these impulses. That's what I mean by expansion. So y of n will be equal to x of n convolution delta of n, right, minus x of n convolution delta of n minus 3 plus x of n convolution delta of n minus 5, right? So this is what we are having. So now if you apply the properties, we can easily find out what my y of n is, right? So this is x of n convolution delta of n, which is equals to x of n, right? So if you simplify this, I'll be having x of n. And now in order to simplify this convolution, I need to apply the time shifting property, right? So x of n convolution delta of n minus 3 is nothing but x of n minus 3, as well as x of n convolution delta of n minus 5, that will be equal to x of n minus 5. So now this is the output response of the given discrete system. What is that? Y of n equals to x of n minus x of n minus 3 plus x of n minus 5. But what we are asked to find is y of 5, right? So in order to find y of 5, obviously we need to find the output response y of n, and then wherever you find n, if you just replace that with 5, I can find my y of 5. So this is your equation, right? So in this equation, what you need to do, wherever you find n, you just replace 5, because we are asked to find y of 5, right? So this will be y of 5 equals to x of, over here we are having a n, so replace it with 5, so this will be x of 5 minus x of again n minus 3, so this will be x of 5 minus 3 plus x of n minus 5, so that will be x of 5 minus 5. So if you simplify this first term, it remains the same. This will be x of 5, 5 minus 3, it is 2, so the second term will be x of 2, 5 minus 5, that is 0, so this will be x of 0. So my y of 5 will be equal to x of 5 minus x of 2 plus x of 0. Now the next question that comes to our mind is, how can I find the values of, or how can I get the amplitudes of these x of 5 or x of 2 or x of 0, whatever. So in order to find these, let us get back to the given discrete sequence. So now if you observe this sequence, what it implies is, at n equals to 0, the amplitude is 1, or in other terms, this is my x of 0 is nothing but 1. So what does this x of 0 imply? At n equals to 0, the amplitude of the signal is nothing but 1. Likewise, my x of 1 is again 1. So on and so forth, my x of 5. So if you observe, this is my n, this is n equals to 5. Over here the amplitude is minus 5. So my x of 5 is minus 1. So let us try to write these values over here. So x of 0 is 1, x of 1 is again 1, x of 2 as well as x of 3, again they are equal to 1. And if you observe keenly, x of 4 as well as x of 5, they are equals to minus 1. So now what we are having over here is, my y of 5 is x of 5 minus x of 2 plus x of 0. So what is my x of 5? X of 5 is minus 1. So minus 1 over here, x of 5 is minus 1, right? And then what we need is x of 2. So if you again look over here, x of 2 is 1. So we are having a minus sign over here. So minus 1, and then we are having plus x of 0, right? So x of 0 is again 1. So if you replace those values over here, my y of 5 is minus 1 plus 1. So obviously what we can say is the value of y of 5 is 1. Again, what does y of 5 implies? So if you draw the output sequence, or if you try to draw the output sequence at n equals to 5, the amplitude of the signal is going to be 1, right? So this is it for today. Thank you.